Hello folks, my name is Christian and I want to show you how to use the SGAM Toolbox for developing smart grid systems within the smart grid architecture model. For this demonstration I'm going to use Enterprise Architect version 10 and the SGAM Toolbox in version 0.3. Okay, let's go. The first task we have to do is to specify a system of interest and its functionalities. In real-world projects we would have to perform a comprehensive requirements engineering first, but for now, a simplified example just for demonstration purposes should be enough. This demonstration example focuses on a facility that is able to produce and store thermal energy. To do so, it is equipped with a combined heat and power plant, a heat pump, and a storage for thermal energy. The operation of the combined heat and power plant and the heat pump affect the distribution system in different ways. As the CHP produces heat and electric energy, it reduces the load to the DS, and contrasting to this, the heat pump needs electric energy for the generation of thermal energy and hence increases the load to the distribution system. The distribution system operator, who is responsible for the stability of the grid, is interested in using the provided flexibility. To do so, he offers dynamic energy prices to the facility once every 24 hours. And now, the facility operates according to the prices. This means, during periods of cheap energy, the heat pump will be activated, which increases the load for the distribution system, and during periods of expensive energy, the combined heat and power plant will be used for the generation of heat, which reduces the load for the distribution system. Okay, with this rough description of simplified demonstration example, we can set up a model and begin the use case analysis task. The first thing we do is to open Enterprise Architect, create a new project. Let's call it Flexible Loads. Okay. Here we got. And now we use the project wizard, which delivers us the SGAM Toolbox here as technology. And we select the SGAM business layer and the function layer as the packages we want to create. These packages help us during the first task, the use case analysis. In addition, I prefer to create a second model. I call it Tools. It's on the second monitor here. Okay. And here I create some packages that help me during development. So the first thing I create is project template package. I will talk about this in a few seconds. Then maybe a sandbox could be useful. Okay, and one more package I use later on for documentation. I call it documentation. Okay, so the project template helps us to define how elements should appear when they are created and placed into new diagrams. So here I create a SGAM function layer diagram first. Again, from the SGAM Toolbox, you select the function layer. Okay, and here I place a primary use case. This looks like this here. Just leave the name unchanged. And what I want to have is, I want all those primary use cases to be placed in a rectangular notation. So I say advanced, use rectangular notation. So, okay, that size is good. And this is the way I want to have primary use cases placed in new diagrams. I save it. And now I can select on the settings and project template package. My project template package, okay, and now every time when I place a primary use case on a diagram, it will appear in that way. Before we start with the system analysis, let me say a few words about some praxis issues. In the perfect world, we assume to have a domain expert who delivers all the use cases and requirements to us, And of course, all those use cases and requirements are created by usage of a consolidated use case template, and of course they're also clear, comprehensive, unambiguous, so simply perfect. These perfect requirements can be used from a technical expert to transfer them into a real system. So this means to develop the system's architecture and to make the system's realization. Unfortunately, as you know, we are living in a real world, so the typical scenario is one like the following. So we have underspecified use cases and requirements, and all of them are of different type of description and different quality. And so we have to find a suitable way to develop a good system despite of that. The key to success here is the implementation of an adequate requirements engineering. So requirements engineering is one of the most critical and quite complex tasks, and going through this in detail here would exceed the tutorial's scope by far. So I won't talk about this here in too much detail. Again, the presented example here is well prepared, and it assumes that all knowledge is already available. Contrasting to this, in real-world projects we would have to iteratively refine our understanding of the system by executing this comprehensive requirements engineering. And hereby the usage of modeling technologies like the presented is of very, very great value for analyzing, understanding and structuring the description of the system to be built. Well, despite the complexity of requirements engineering and the out-of-scope thing, I want to draw your focus to some essential aspects according to this. Okay, the first thing I want to put your focus at is the clearance of the roles and the reliabilities within the project team. So before you start a system analysis according a specific system, please make the roles and reliabilities within this project team clear and name them. So if you only remember one thing out of this tutorial, then please this really clear the reliabilities before you start the system analysis. Even if this sounds very clear and logic, quite often this part is neglected, so please remember this one. Okay, we have indeed 3 essential roles which are necessary during this phase, and I will discuss them in a little bit more detail here. So the first role is the so-called product owner, and this role for us is the one instance that has the need for a system to be built. So we say he or she knows what he wants to have, and he is able and willing to answer our questions according to systems. The product owner is a domain expert, which does not necessarily mean that he's a technical expert as well. This is okay. Typically, the product owner is not able to formulate good use cases and requirements as we are willing to work with during requirements engineering. So it is basically our job as engineers to pick up the ideas and inputs from a product owner, to analyze them and to transfer them into good use cases and requirements. A very important reliability of the product owner is that he collaborates with the requirements engineer, and he must be available in order to answer questions. The second role is the requirements engineer. This is the one guy that tries to understand the product owner's needs. So he is responsible to learn the product owner's language. This means to establish domain know-how. The product owner is the customer of the requirements engineer. So we as requirements engineers have to learn the customer's, say, product owner's language. Well, and the basic task of the requirements engineer is to formulate use cases and requirements based on various product owner inputs in whatever quality they are delivered. And the last role is the system architect, who is finally responsible for architecting the system based on the requirements as were elicited before. After we have clarified all the reliabilities within the project, we can start with the system analysis. Once more, the goal of the system analysis is to establish an understanding and to get a documentation of the product owner's needs and desires. So what we want to have is a comprehensive description of the system's functionality and specification. The basic tasks during system analysis are elaborated from the product owner and the requirements engineer as a team. And let's take a look at these tasks in more detail. So first, the requirements engineer fetches all available input about the system and the system context that is to be built. This input is analyzed and we try to identify open issues we want to clarify with the product owner. So after this, iteratively, we make some product owner assessments or some workshops where we try to clarify all those open issues. And after this, we can try to develop the current understanding. We do this by modeling, and we do this iteratively until the product owner agrees and he says, yes, this is the one system I want to have built. In parallel to this, we have to execute all the tasks from classical requirements engineering as we know. So this means we have to identify additional stakeholders, we have to identify the developer requirements, and of course we have to mention some issues like quality requirements. Let's say like here privacy, reliability, availability, maintainability, safety, security, and many more things. Again, the demonstration here focuses on the usage of the toolbox, and I skip the iterative requirements engineering process here, so I do not present it in this tutorial. If you want to know more about the underlying requirements, please feel free to contact me, but nevertheless please keep in mind that using modeling techniques delivers great value for analyzing, understanding and documenting use cases, requirements and any other aspect of the system. So modeling is one of the best friends of a requirements engineer. Okay, after this short preacher about the importance of requirements engineering, we can go back to the system analysis and take a look at the steps we have to perform. Okay, the first step we have to do is to develop the business case model. As mentioned before, this happens as an iterative task. Even in this tutorial it is shown as one straightforward step. So the task we have to do is to identify the involved business actors, their business goals, the corresponding business cases, and the invoked high-level use cases. So we say a business actor has business goals. These business goals are realized by a business case, and each of these business cases invokes some high-level use cases in order to be executed. So what we want to have is we want to understand through analyzation the product owner's needs and document it as a model. The diagrams we use here are business layer diagrams. We say business case analysis. After having the business case model iteratively refined until it's fine, we start with the development of the high-level use case model, again an iterative task. And here we try to decompose every high-level use case in smaller primary use cases, and we try to model their collaborations, their interactions and their activities. The diagram we use here is a function layer diagram, and we call it high-level use case model. Again, this is here also presented as a straightforward task, but in real life we would iteratively refine them, discuss them, analyze them, and go on until everyone in the team agrees with the documentation and the realization of these high-level use cases. Okay, and after these few words about system analysis and requirements engineering and some issues from the praxis, we can go back to our previously prepared model and start the system analysis. Okay, after having our model prepared that way, we can start with the function analysis. So we start this task in the business layer. So we open the ESCOM business layer here, and as you can see, the Wiz had already created some template model for us that illustrates how to use this layer. For now we don't need this, so we simply delete all of them here in the model here. Okay, and now we can start modeling our own business cases. So the first thing we do, we identify which business actors are involved in our system, so which stakeholders have interests. So the first one is the distribution system operator, simply call it DSO. Of course, you could describe it here in more detail, or you could use tagged values to describe some attributes of the distribution system operator, but for now we are fine with the name. Okay, then another stakeholder is the facility operator. So again, we place a business actor here, call it facility operator. Okay, facility operator, here we are. Okay, the next thing is we try to identify which goals they are following. So the first one, the DSO, has the goal, he wants to delay the distribution system upgrade. So we call the business goal delay distribution system upgrade. Okay, so there is a dependency relation between them. Okay, and one possibility for the DSO to reach his goal is to use flexible loads. So now we know we have a business case here, we call this a business case. A business case is a possibility for a business actor to reach his business goal. So this business case is called utilize flexible load. Okay, this means if the distribution system operator is able to turn flexible loads on and off, he can prevent spikes and peaks, and so he can delay the upgrade of a distribution system. So we have a use relation between the business actor and realization between the use case and the requirement. Here we say the business case realizes a requirement, or in that case realizes a business requirement, or more precise, a business goal. The same thing we do here on the side of the facility operator. Here the facility operator follows the goal, the business goal. He wants to optimize his energy costs. So, sorry. Okay. Again, we have a dependency relation here. Okay. And one possibility for the facility operator to optimize his energy costs is to provide flexible load, so he can make use of variable prices or something like that. So we have the business case here, provide flexible loads. So, okay, again here a use relation. And here this business case realizes the business requirement or the business goal. Okay. Okay, and that's the two stakeholders involved with their individual goals and the corresponding business cases to reach these goals. Furthermore, we have a relation between these two stakeholders, and this relation is a flexibility contract. So, oops, sorry. We call it flexibility contract. Maybe you also could introduce a business case here if you want to describe how this contract is established or so, but for this demonstration example it's enough to show that there is a flexibility contract between these two business actors. Of course, you also could add a note here, for example. Okay, I won't do this. You could add a note to describe it in more detail, however you want. And in addition, we also want to show that there are dependencies between these two business cases, so we simply use a dependency relation, but this is in a bidirectional way. So just switch the direction to bidirectional. Okay, simple little bit layouting, and that's it. that's how our business cases look like. These are the stakeholders, their individual business goals, and the business cases they are realizing in order to reach their individual business goals. Okay, after modeling the business cases, we are interested in which specific high-level use cases are to be realized in order to fulfill the described business cases. So we know one high-level use case from the introduction, which says that we are able to control the electric load of thermal energy system. Okay, and this high-level use case is invoked from this business case here. Okay, so of course this this high-level use case, you could describe it in more detail maybe here in the notes field. In addition, you have the possibility of adding tagged values, which means some attributes. We also provided some tagged values from the toolbox already. This list will be extended in future. Just to say, everything that helps to describe your use case is valid to enter. Of course, also you could provide links, you could provide files or hyperlinks here, or anything that helps. Okay, even if we only have one high-level use case here in this demonstration example, of course, this business case typically would invoke more high-level use cases. So let's say, for example, there is an e-car charging system that could be used for providing flexible loads, like I say, scheduling the e-car charging, or you could have some demand response management system. Sorry, just demand response. Sorry. Okay. However. Okay. So we know which high-level use cases are invoked in order to fulfill a specific business case, which again is used from a business actor to reach his specific business goals. And what we do next is we take a closer look at one specific high-level use case, how it is working and how is it composed into primary use cases. Therefore, we are going to make this high-level use case composite and decompose it into primary use cases. But before we do so, we're gonna clean up our model a bit. So I create one package here for the business actors. Okay, one for or I leave the business actors and the goals together. Depends on how you prefer. Okay, and then I create one package for every business use case. So I could create here the package and stereotype it as business case package, or in more easier ways, just use this business case package, create it here. Say the business case is utilize flexible loads. Okay, and provide flexible loads. So okay, so we got our two packages here with the correct stereotype. Can remove them from the diagram, don't need them here. Simply move the business cases to here. As you can see, the high-level use cases we created in this diagram also are located in the SGAM business layer package, but we want to have them in the function layer. So I'm going to open the function layer and move the three high-level use cases down to here. Okay, and now I can begin structuring my high-level use case models here again. So for example, I take this package from the wizard, delete the things I don't need, and rename this package here to control the electric load of thermal energy system. Okay, this, move it to here. Again, we have a business case from the wizard we don't need anymore. Okay, and so on. I won't do this now for all the high-level use cases, but commonly it's quite important to keep some structure here in the model. Okay, now let's start to make this high-level use case composite. So first thing, we create a new diagram. We say new diagram, composite structure diagram. Okay, just copy this high-level use case to the clipboard, and then we can open the newly created diagram, which is this one here. Okay, open it here. Normally you could open the diagram by double-clicking the element in the window here, but unfortunately the window capturing tool compromises my mouse, and so I have to navigate within the project browser here. Okay, here we have our high-level use case, and now we want to decompose it into primary use cases. So after analyzing the information we got from the system description in the introduction, we know that we have one primary use case in the beginning. This, I don't know, let's call it operation plan. Okay, this primary use case works the following way. Once a day some communication takes place between the distribution system operator and the facility operator when the new energy prices for the next 24 hours are communicated, and based on this information the energy management system later on will determine its operation plan for the next 24 hours. This means it will determine when it will use the combined heat and power plant and when it will use the heat pump. So here we have this one use case. The next primary use cases focus on the control of the thermal heating system. So that's a quite simple control system. So it starts in the beginning with data acquisition phase. So in this use case, don't know, maybe the temperatures of the thermal storage will be collected. Then the next primary use case focuses on the control logic, let's say control heat. So in this use case an algorithm takes place which analyzes the data from the thermal storage and the operation plan, and depending on this algorithm it will determine how to set the two heating systems, so the heat pump and the combined heat and power plant. So we have two primary use cases here. This means control heat pump, let's say HP, and control CHP. Okay, so our high-level use case is built up of these 5 primary use cases. So after we identified which primary use cases are used in order to fulfill this high-level use case, we want to model how the collaboration between them looks like. Well, there are many possibilities to depict something like that. You could use any kind of activity diagrams or whatever you want, but I prefer one special way that is, in my opinion, quite fast, and I will show you how to do this. So the first thing is I open the properties of this high-level use case, then I open the scenarios tab and I show which primary use cases are invoked. It's quite easy to do by just right click and say link step to use case, and now I can select which primary use cases are invoked. So I navigate to the primary use cases and select all of them. This means the first one is data acquisition. Oops, sorry, it's the first one is operation plan. Then we have invoked the data acquisition. Okay. Next we have algorithmic control operation, control heat. Okay, here we have the next the control of the CHP and the control of the heat pump here. Okay. Okay, so you see here that the invocations are already integrated to the model itself and depicted here in this diagram as well, so you can arrange them the way you want. I don't mind for now. The next thing we can do is we open again this dialog, the property scenarios, and now we can generate out of these informations an activity diagram, simple selecting here the menu and activity. Okay, okay, and here we get an straightforward activity diagram, a starting point. So this generated diagram doesn't reflect reality, but it is a nice starting point for modeling how the interrelations between this use case invocations take place. Okay, and the modeling of these interrelations could look like follows. So we know for the first that there are two different paths. We have one path that is executed continuously, that's the control path, which starts with data acquisition, calculating the operation points for the two heat generating systems and setting the two systems to their new operation point. And here we have a second path, which is executed once a day, and this path calculates the operation plan for the next 24 hours. So the first thing is we want to show that there are two different paths, so we make use of the partition element. So we have one partition that says executed once every 24 hours. Okay, and we have one partition that is executed continuously, so we say it's continuous operation. Okay, what I also do mostly, these elements here are use case invocations of primary use cases. I also turn the color to blue to signal that it's the same one like primary use cases. Okay, now I turn these partitions by 90 degrees. So here we have the once every 24-hour path. Here we have the continuous operation path, again turned by 90 degrees. Okay, and now let's take a closer look at what happens here. So let's start with this operation plan. Indeed, this action or this use case is triggered if the new prices are received from the distribution system operator. So we make use of a receive event. Here we have, and we say receive energy price table, something like that. Okay, here receive the energy price table, and here we have control flow from the energy price table to this use case. Okay, that's it for now. Here we move this a little bit down. Okay, what do we have on this side? On this side we have used the starting element here because this is the continuous operation. Okay, sorry. So here we have the data acquisition. This one we don't need. Okay, something like that. Here we have the control flow from the starting event to data acquisition. Okay, and during data acquisition, let's say we have one data element calculated, which is the temperature of the thermal storage, so we don't need this control flow here. And to show that the data is created here in the data acquisition use case and used in the control heat use case, we make use of an object flow. Here we put it from data acquisition to control heat, and here we can depict that we have objects transported from the first use case invocation to the next, and this object is open it that way. This object is the thermal status, or let's say the storage temperatures. Okay, same thing here, the storage temperatures. Okay, so we have depicted the relation between these two use cases. The same thing from here to there. From the operation plan use case, we transmit some data that is called the operation plan to this primary use case control heat, which tells the algorithm what to do, or which is used as parameter to the algorithm. So again, we use an object flow element. Okay, and here we transport the operation plan. Okay, again the operation plan. Okay, so okay, and now we see that this use case has two input parameters. One is the storage temperature and one is the operation plan, and using these two parameters it's doing some algorithmic calculations, and it outputs two results. One is the set point for the heat pump here. Okay, so we have the heat pump set point. Just copy this. Okay, my mouse is a little bit annoying. Okay, heat pump set point, and the same thing here with the combined heat and power plant. So again an object flow. So this one is the CHB set point. And also here CHB set point. Okay, okay, this one goes to there. Okay, and here we have depicted how these primary use cases interact with each other in order to fulfill the high-level use case. Okay, I just saved this diagram, and now I would like to see this all in the same diagram, so I go back to the main diagram here. Okay, sorry, that is open. Okay, just rearrange these elements here a bit. I have the operation plan here, the control algorithms. Here is the data acquisition. Okay, here is the operation plan acquisition. Okay, and here are these two, the control of these two heat systems. They are all invoked by the high-level use case. Okay, now I can use this diagram here and put it into the other one. Okay, so okay, and now I have in one picture, I see which primary use cases are invoked by the one high-level use case and how their interrelation is looking like. And now also can show these function interrelations in a more explicit way. So I use the function interrelation connection, and I see that the operation plan use case is see it here in the use case invocations description. Here you see that the operation plan use case is linked to the algorithmic control heat use case. I have one interrelation here. I have one interrelation between the data acquisition and the algorithmic use case here, and again one here and one here. Okay, and that way our high-level use case is decomposed in various primary use cases, and it's depicted how the invocations of these primary use cases work together in order to fulfill this high-level use case. The next thing we're going to do is to model the single primary use cases in more detail. So first, I'm going to add a new diagram to this primary use case. Simply say new diagram, composite structure diagram. Okay, and I just copy this use case to the clipboard. I open the new created diagram and I paste this use case here. This is the place where I'm going to model my use case. Typically the basis for a description of our use case is some textual description, which could look like this one here prepared. This tells us step by step how the use case is working. So it says first the facility energy management system connects to the distribution management system with its authentication credentials. Next, the DMS acknowledges the connection. The DMS requires the energy price table, the DMS transmits the energy price table, and VMS calculates the operation plan. There is a quite convenient possibility to use this text for modeling, so we simply copy it to the clipboard. Then we open this use case. We open the structured scenario specification, and here we can say create structure from clipboard text. It's new line delimited, and so we get a step-by-step description of all the single steps. What we can do next is the following. We pass through the text and we try to identify which are the individual actors that are interacting with this use case. And in this case we see the energy management system, the EMS, and the DMS. So what we do next is we create these involved actors here as SGAM actors. This one was an EMS. It's working together with this use case. And we have the distribution management system. Okay, the DMS. Okay. If we open this use case now again, go to properties, scenarios, we see that the actors are recognized and labeled in blue with underlines. So what we can do now is we can generate an activity diagram. Let's make this. Okay, and we generate an sequence diagram. Okay, so now look what we got. Here in the model we can see that under this primary use case, two diagrams were created. First the activity graph, and here the sequence diagram. If we open the activity graph here, we see it's a simple, straightforward activity graph. In real-world projects we would go on and model alternative paths here, model exceptions and so on, but for now it's fine to see how the activity can look. We use these activity diagrams here to identify which information objects are used to fulfill the use case. So here we switch to our SGAM Toolbox function layer toolbox. Okay, here we have the information object elements. So here the first one we need are the authentication credentials that are needed for the EMS to connect to the DMS. So we call it authentication credentials, and here you could describe it in any way you want. For example, you say it's user password, some policies, however you want. Of course, you also could use tagged values or something else to describe these information items in more detail. Okay, so we have this information item. This step depends on this information item. Okay, here we have an acknowledgement, that's okay. Then we have energy price table, that's an important information object. So we say energy price table. Again, here you could describe how this energy price table information object looks like, which informations are included, and so on. I don't write this now, just leave it here. We have energy price table as information object. Okay. Dependency, and what else? Again, the energy price table is needed here in this step. Operation plan. Then we have the operation plan. Okay. Again, here you could describe how the operation plan should look like. Okay. Let's make it. Okay. Dependency. Okay. That's fine for now. Okay, now we switch to the sequence diagram again. We open it here. And now we want to show here which information objects, which physical objects are used during this use case. So here in the first one we have the authentication credentials. We can place them here by advanced information flows realized. Here we can select the authentication credentials. Okay. And now we can see here this little black arrow which tells us that here a physical object is conveyed beyond this connection. So whenever we want to look at this diagram, we can later on use the mouse, click right and say find items conveyed, and we will get in the project browser the physical information object that is conveyed here. We do the same thing here with the energy price table, which is transmitted. Say advanced information flows realized. Here we have the energy price table. Okay. 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 And here we have the operation plan. Okay. Operation plan. Okay. So this is quite useful to have the physical information objects linked to each of these connections. Okay, now we go back to the original diagram of this primary use case. So here we see the use case again and the involved actors. Now we insert the activity diagram. Okay, call it, just leave it. Okay, and the sequence diagram again we also put into here. Okay, you see here basic path. I will talk about this in a few seconds. Okay. Okay. So, okay, and in this view you have a simple illustration of how the use case works. You see here the primary use case, you see which actors are involved, you see the activity graph, and you see a sequence diagram. Doesn't look very fancy now, but you can do this better in real life projects. But please keep in mind this is only a very short description. Of course you have many more possibilities to describe your use case and you should use them. For example, if you open the use case again, it's very useful to make use of the constraints where you can define preconditions, post conditions, and of course in the scenarios we only have one basic path, and of course you could create alternative paths, you could define results, you can add requirements to this use case, so you should make use of all these features to describe the use case as good as possible. But for now, for demonstration purposes, this is enough. Okay, I skipped forward a bit, so what you didn't see now, I reproduced all these steps for the other primary use cases, so they're all described in the same manner. In addition, I cleaned up my model a bit, so I introduced sub-packages for all high-level use cases and below them for all primary use cases that way. So what I want to do now is to describe this a little bit more in detail and map it to the ESCOM plane. So one thing that's very useful is the classic use case diagram. So I add a new diagram here, make it ESCOM function layer type, and here I want to depict the classic use case diagram for the high-level use case control electric load from thermal energy generation. So the easiest way is to put the high-level use case into here and to say insert related elements, just to get all related high-level primary use cases. Okay, don't need this anymore now. Okay, here I see that there is a business case as well. I don't want to have this one here. Okay, so here we got our use cases. I want to hide the interrelations here. I can say visibility hide connector, or more easy, I go to diagram, advanced visible relations, and say don't want to see them here. The next thing is I want to have the actors placed, put all the actors in. Okay, and here I get my use case diagram, which again clean up a little bit. So we have the combined heat and power plant, we have distribution management system, we have energy management system from the facility, we have here is this the heat pump, control heat pump, so control heat generation, operation plan, thermal storage. Okay. So okay. Okay. Just to illustrate which use cases are involved. Okay, that's the classic use case diagram. For the high-level use case, I just put a boundary around this. This was electric from okay. So that's the classic use case diagram. Save it. And what I want to do next is I want to map all the primary use cases to the ESCOM plane. So again, new diagram, ESCOM function layer. Okay. Here I want to have all the ESCOM plane. So diagram, swim lanes and matrix. Here I can select the ESCOM function layer. Okay. Don't forget to set it active. And now I see all the domains and zones. Here I want to show which use cases are in which domain and zone. So I can again insert all the use cases like I did before, but it's more easy to go to the diagram we made before and simply copy all of those use cases. Okay, just paste them here. Here I want to see the interrelations, so I make them visible. Okay, I seems as if my project template package is broken. I want to have them rectangular, but for now it doesn't matter. And here I can say, okay, I have the, let's put in, I have data acquisition and the control of these two systems. I place them, just resize this a bit, because so I think we're working in distribution and DER mostly. Okay, so I guess this will look something like this. Okay, we have control heat generation, and the operation will probably be here. So if you want to, you also can insert here the actors or system components later on, whatever helps to describe the system's functionality. Now that we know which domains and zones are affected by this one high-level use case, we can bring this information to the SGAM business layer in the following way. First, we create for the one business case we're interested in, let's say provide flexible loads this way, we create one new SGAM business layer. I make this here. Okay, let's say SGAM business layer. Okay. Again, I want to see the SGAM plane, so it's a diagram, swim lanes and matrix. Select SGAM business layer matrix. Okay, don't forget to set it active. Okay, here we go. And here I want to depict which domains and zones are affected by this one business case. So first I put the business case into here, then I want to see which high-level use cases are related to this. I say insert related elements. I select the high-level use cases which are, we've modeled now, control electric load, control e-car charging, we didn't model, demand response as well, but they are affected. Utilize flexible loads is another business case. So we have these three high-level use cases. Okay. I don't want to see the relations here, so I just make them invisible. Better way is here to go to diagram, advanced visible relations, deselect the visibility. Okay, now I know we have modeled. Okay, double click, open it here. We see control electric load from thermal energy. We see here, we see which domains and zones are covered. So it's distribution and DER from operation to process. Go back. Sorry. Here we are. So send this one to the back first. Okay. Make it rectangle. Advanced, use rectangle notation. And so I know it's distribution and DER, so this high-level use case would be placed here. For example, the one from demand response management, I don't know. Let's say it could be placed, for example, these domains and zones, and say control e-car charging maybe would be overall here. I don't know, you have to decide in detail which domains and zones are covered for each high-level use case. Now for demonstration, I assume the way that's demonstrated here. Okay, I assume this one is going from here to here. Okay, just for demonstration. I'll make it a little bit smaller. Okay, and so I say the business case covers the maximum of all affected domains and the maximum of all affected zones. So this case, it would be the same like this high-level use case here. So I say this business case is from here to here. Okay, and I send it to the back again. So we didn't focus to the business layer very much until now, but maybe you can use this information about the covered domains and zones to identify which regulatories you have to mention or whatever you want to do here. Okay, with this step we finished the system analysis, and let's look what we got so far. We started with a business case analysis, and here we identified which business actors are following which business goals and which business cases realize these business goals. Furthermore, we found out which high-level use cases were involved to realize the individual business cases. For every business case here, we developed a business layer which shows us which domains and zones are affected following the individual high-level use cases. Each of these high-level use cases is described in more detail, as you can see here, where we identified which more granular primary use cases are involved, how do these primary use cases interact, and in addition we get these classic use case diagrams that depict us which actors are involved. The next one is, for all these primary use cases, we draw a SGAM function layer which shows us which domains and zones are affected by the individual primary use cases. So, and of course, each of these primary use cases here is described in more detail by means of activity diagrams, which also show us which information objects are used, and a sequence diagram that illustrate communication issues. I usually separate use cases here between two types. I separate between algorithmic dominated use cases, here the activity diagram is more useful, and communication use cases where the sequence diagram is better to understand. Okay, and that's the system analysis phase. And what we do next is we make the model transformation from the functionality to the technology. So we want to map these logical actors from the functional analysis to physical actors in the component layer.